Hello, thanks for tuning in to your chemistry video. We are starting a new unit, and for those of you that really haven't liked all the math we've been doing, you'll be very pleased because our next unit won't have nearly as much math in it. So let's go ahead and get started. This unit is called Atomic Structure. Some of it is going to be a review for you, and some of it will be totally new. So let's just go ahead and get started with the first video for today. All right, so our learning target is I can place atomic models in chronological order and explain the evidence that led to each new model. Before I begin, I want to just kind of break down that learning target just a little bit. First of all, making sure that you understand that this word here, placing the models in chronological order, means that what I want you to be able to do is to see how the model of the atom has changed over time. So what originally was the model that was accepted in science is not the same model that we see today. And so that's what I want you to really focus on as we go through this is recognizing how the model has changed over time. All right, so what you're going to see on the boards today is several different scientists that had huge contributions in the world of science that led to our models of the atom. And so this first scientist on the board here, John Dalton, I don't want you to think that he just came up with this all on his own. He actually worked with many other scientists and built upon the ideas that had been discussed among philosophers such as Democritus and Aristotle for a long, long time. But John Dalton was able to develop a theory about atoms, and he published that in the Dalton's Atomic Theory, and you can see up here that that was in 1803. Now, I do want to go over each part. There's 5 parts to Dalton's Atomic Theory, and I want to go over each part briefly. The first thing is what we already know, which is that matter is composed of atoms, and of course we know that atoms are very small. Secondly, atoms are indivisible and indestructible. Now, if you think about that one for just a minute, you probably already recognize that that has already been shown to not be true because we can divide atoms into separate parts. But that's what we'll see over time, that as we get more information, that the model of the atom changes. Dalton also said that atoms of a given element are identical in size, mass, and chemical properties. That word right there should say in. Okay, so atoms of a given element are identical in size, mass, and chemical properties. So basically what that means is if you have an atom of hydrogen, every other atom of hydrogen is going to be similar or identical in size, mass, and chemical properties. And then number 4, different atoms combine in simple whole number ratios to form compounds. We'll talk more about that specifically when we start talking about chemical reactions. And then the 5th part, which I'm going to have to adjust here a little bit so you can see, okay? The 5th part says that in chemical reactions, atoms are separated, combined, or rearranged. So those 5 parts are the parts of Dalton's atomic theory that kind of set the stage for how the model has evolved over time. And like I said before, that many scientists were thinking about this and working on trying to understand what an atom looks like, because when we can't see something, it's hard to make sense about what's going on without having some sort of visual model. And so one scientist, J.J. Thomson, built upon other scientists' work that had already proved that atoms contained a positive charge. However, he used a cathode ray tube to discover the electron. And so you can see here that electrons, hopefully this isn't totally new, but electrons have a negative charge. So he discovered the negatively charged electron using the cathode ray tube. Now there's another video under this unit on YouTube. It's just maybe a minute long, but it shows you how he discovered the electron. So you can check that out. I will show that in class as well, but it'll kind of give you an idea of how he discovered the electron. Once he discovered the electron, he knew that there were negative charges, as indicated by the orange with the little negative sign, that there were negative charges that were kind of placed randomly throughout this positively charged lump of matter. And he called this the plum pudding model. Now, most of you have not had plum pudding. I haven't either, but apparently that was a really popular dessert back in the 1800s. I think that a chocolate chip cookie model makes more sense to us, where the positively charged part would be like the cookie dough, and the negatively charged electrons would be the chocolate chips. So we can call this the chocolate chip cookie model, where we just had a lump of positively charged matter that had randomly placed negatively charged electrons. And make sure you get these pictures down. Okay, so J.J. Thomson was credited with discovering the electron, and once that was in place, other scientists continued to work on understanding not just the placement of electrons in the atom, but also understanding how they work. But another scientist named J.J. Rutherford decided to look a little more closely at the nucleus. So you can see here that Ernest Rutherford developed his work in the early 1900s. And he performed what's called the gold foil experiment. And once again, it's kind of hard to explain it. It's much better to watch it. And so there is a video about the gold foil experiment on this unit on my YouTube playlist as well that you can watch. But it explains how that in this experiment, he discovered the nucleus of an atom. And what he discovered is that most of the atom is empty space. And it's only that all the positive charge is in the center of the atom instead of distributed throughout the atom like J.J. Thomson thought. And so with all the positive center in the middle, he also discovered that the center of the atom was very dense, meaning it had most of the mass of the atom was in the center. And he called that the nucleus. And so here is a picture of a model that would reflect Ernest Rutherford's experiment, where the little green plus in the middle represents the tiny but very dense nucleus. It has a positive charge. And then he didn't really study the electrons too much, but at that time the thought was just electrons were somehow around the positively charged nucleus. Okay, so moving on, a student of Ernest Rutherford's was Niels Bohr. And when Ernest Rutherford was studying the nucleus, he decided to look a little more closely at the electrons. And he did a lot of work, which we will actually study more closely a little bit later on in this unit about atomic structure. But I can just give you the basics right now about the Bohr model of the atom. This model focused on the electrons in Rutherford's model. So if you remember in the last picture you drew, you had electrons that were just kind of spinning around the nucleus. Well, in this case, Niels Bohr did some experiments that helped him understand that electrons actually give off energy. And because of this, he was able to see that electrons give off different amounts of energy. So the first thing we need to know is that, first of all, electrons travel in orbits around the nucleus, and that each orbit is defined by a certain amount of energy. Orbits are sometimes called energy levels or electron shells. And once again, if you think way down deep in your brain, you probably covered this a little bit your freshman year in integrated science, where you had electron shells around a nucleus, and it probably looked something like this, where you have your nucleus in the middle with a positive charge, and then rings around the nucleus with electrons in there. The other thing that Niels Bohr was able to understand is that the energy of the electrons increase as the distance from the nucleus increase. So the electrons that are out here have more energy than the ones that are closer to the nucleus. This type of model is called the planetary model because it mimics a little bit like the solar system, where the nucleus is the sun and the electrons are the planets spinning around the sun in clearly defined orbits. And that brings us to the model that is most accepted today. And even as I speak, there is more work being done to test and refine the model of the atom. But for now, we're going to go with that. This is the most up-to-date one. And this is called the quantum mechanical model. The reason that this model came about is because of the work of two scientists, which you don't have to write down, but their names were Heisenberg and Schrödinger. And they developed a lot of mathematical concepts and did a lot of mathematical calculations to help understand where electrons might be in the atom. And what Heisenberg eventually decided and understood was that it's actually not possible to predict the location and the velocity of an electron. This is actually called the Heisenberg uncertainty principle. And the quantum mechanical model is based on this principle. In this case, electrons exist in a cloud. Let me write this in a little bit because it got smudged. So electrons exist in a cloud, and sometimes you've heard that called the electron cloud. But specifically, the region in the cloud where electrons are most often found are called orbitals. Okay, that's probably a new word, and we'll talk more about the arrangement of electrons in orbitals. But this is the quantum mechanical model, and it kind of looks crazy right now, but I'll help you understand that this is actually a very well-designed model that helps us understand where electrons are in the atom. So that's it for today. If you have a little extra time and you want to watch the videos about the cathode ray tube and the gold foil experiment, that would be great. That'll kind of help you understand where that information was, and also how they used that to develop the next new model of the atom. So, okay, that's it. You guys have a great day, and I'll talk to you soon. Bye-bye.